Hello, my name is Acadia, and for my project I chose to research the evaporation rate of alcohols. In this investigation, the scientists will be investigating the evaporation rate of alcohols with the equation delta T, or change in time. The evaporation rate of alcohols is important to chemistry because it displays how hydroxyl groups and different amounts of carbon and hydrogen affect the evaporation rate of alcohols. The scientist is interested in this investigation because she is interested in biochemistry and chemistry. When an alcohol evaporates, the reaction is called an endothermic. An endothermic reaction is when the reaction absorbs energy. This happens because the amount of energy needed to create the products is more than that from the reactant, and it takes extra energy from the surrounding area to make the reaction happen. The opposite reaction, an exothermic reaction, is when the reaction releases energy. This occurs when the energy sum of the reactants is greater than the products and the remaining energy is released. When an endothermic reaction occurs, the reaction absorbs energy, which will make the solution seem colder. In an endothermic reaction, the energy of the product is greater than that of the reactants because the reaction absorbs outside energy instead of releasing energy. Alcohol is a general term used for any molecule that contains the hydroxyl functional group. This functional group appears on a molecule as negative OH or negative HO. This group consists of one hydrogen atom and one oxygen atom. This group is polar, as the oxygen side is slightly negative and the hydrogen side is slightly positive. This hydroxyl group is a group found in sugars as well as alcohols. An alcohol is a substituted hydrocarbon that contains one or more hydroxyl groups. A hydrocarbon is a compound made of a chain of hydrogen and carbon. Alcohols have higher boiling points than hydrocarbons of the same size because of their hydroxyl group, which allows them to form a hydrogen bond with water and also increases their boiling point. As the hydrocarbon chain gets longer, the boiling point increases, so methanol, 1 carbon, will have a lower boiling point than ethanol, 2 carbons. Roughly 45% of the world's methanol, CH3OH, is used in fuel. Methanol is used to make plastics and synthetic fibers. Methanol is extremely toxic and can be produced from plants. Methanol is formed when hydrogen and methane, CH4, is replaced with a hydroxyl group. Methanol will form a homogeneous mixture with water, H2O, because of the water's attraction to the hydroxyl group. Ethanol, C2H5OH, is the most abundant alcohol that occurs in nature. Ethanol is produced naturally by the action of yeast or bacteria forming on the sugar stored in corn, wheat, or barley. Ethanol is the primary ingredient in alcoholic beverages and has a depressive effect on the nervous system. Even though alcoholic beverages are the most common use for ethanol, it can also be used as a disinfectant. As well as being the most common alcohol in nature, ethanol is also the most used alcohol by humans. Propanol, C3H7OH, forms a homogeneous mixture with water as well as some other organic solvents. It is a corrosive, colorless, and flammable liquid. Propanol is used in rubbing alcohol, which gives this product a distinct smell. Propanol is also used as a fuel, however it is not commonly used because of its flammability and is very expensive to manufacture. Butanol, C4H9OH, is an alcohol that is often consumed by humans, however not as quite as often as ethanol. Butanol is a natural product of carbohydrate fermentation and found in cheeses and some alcoholic beverages and even fruits. Butanol is easily evaporated at room temperature and with a melting point of negative 89 degrees Celsius, negative 128.2 degrees Fahrenheit, and its boiling point of 118 degrees Celsius, 442.2 degrees Fahrenheit, butanol is an extremely versatile alcohol. During this experiment, the scientists will evaporate methanol, ethanol, and propanol. Then, based on the analysis of the structural formulas and the evaporation rates of the first 3 alcohols, the scientists will formulate a hypothesis on the evaporation rate of butanol. This experiment will help scientists have a better understanding of how the proportion to hydrogen to carbon to hydroxyl groups affects evaporation rates. Thank you.